and send an invitation. For some weird reason, I don't know what's happening. The plugin I use to keep track of the sessions, this is fine. It's working just okay. All right. So we've covered quite a bit here, but before we start, right? Before we start, I wanted to give us a heads up. I'm sure we've all seen the emails that have been flying around. Emails as they relate to a series of pending assessments. Some of these are trivial, like assessment number or assignment number 8 and number 9 really involve you creating a Slack workspace and a Trello board, respectively. I've noticed a good number of you have already started doing that, which is commendable, really. If there's stuff that you can do quickly, why not get it out of the way, right, instead of procrastinating? And then what you notice is that assessment number 10, 11, and 12, or assessment 10 through to 12, related to requirements engineering. So we first of all, we start off by giving you a task, a very simple task. If you look at assessment number 10, which requires that you, in your respective groups, identify a comprehensive list of all potential stakeholders associated with the topic that you're working towards in your respective groups. And then in assessment number 11, we provide you with a task that requires that you identify an appropriate measurement instrument that's going to enable you to elicit requirements. Now, what you notice is the part to do with identification of stakeholders and you coming up with elicitation techniques. You're not submitting anything, right, at this point. And the reason is simple. Most of the activities tied to these assessments are really milestones. But ultimately, both assessment number or assignment number 10 and 11 are supposed to be used as input to assignment number 12, which is due on the 8th of August. So 10 and 11 are trivial. They're both due on Monday next week. However, assignment number 12, which is the specification document itself, is only due on the 8th. So you have 2 weeks and 2 days really remaining, which is quite a bit of time. Part of the reason why we're doing this is because we obviously still working towards the current module where we're looking at requirement specification. Okay. Anyways, so with that being said, I suppose we can proceed, unless if there are any questions that people might have regarding the assessments. In addition, what we've done is we've asked the tutor, Elijah, to actually walk you through a series of tutorial questions, problem sets, if you will. So here's to hoping that this is number 5 or something. Here's to hoping that these things are beneficial to you. All right, on with it. So when we met last time, we had a discussion of so-called requirement specification notation. So different ways in which we can represent requirements formally. We realized that we could leverage something that is intuitive to the average human being, which really leverages natural language notation. So this idea that you just use in our case, it's just English, right? And you structure requirements using just sentences and paragraphs. However, we also realized, or we discovered, that you can actually organize these requirements in a structured manner. So you can leverage so-called structured notation, where you're certainly using natural language notation. However, there's some predefined structure that you're following. So something akin to a template. There's form-based notation, where you essentially just fill out some kind of predefined form. Similar to structured notation here, only thing here is that you're working with some sort of structure that mimics a form, right? You have labels and then just filling in the blanks here. There's also tabular notation. In essence, you structure this information using a table, And the classic example that we used is use case description, right? Where we showcased how you specify comprehensively a given use case. So you provide information like the use case ID, the use case name, the triggers, the preconditions, the post conditions, the actors that would be interacting with that use case, right? A whole range of things here. And then finally, towards the end, we introduced something that is going to be covered at length in lecture series number or module number 6 when we look at the unified modeling language. We discovered that we can use so-called stick figures, right? We can use the use case notation, which allows us, if you look at the graphical notation of use case diagrams here, which allows us to represent interactions that happen as the system is operational. So interactions from the perspective of what we introduced as actors, entities. Notice I'm not saying users or human beings. It's entities that interact. Entities that interact with that would be interacting with the system. Okay. And I said that in as much as we're going to spend quite a bit of time studying what you're seeing on the screen right now, it was worth mentioning the fact that these stick figures and these ellipses and these solid lines here mean something, or they would actually mean something to an expert who would be wanting to interpret this sort of information. So for instance, your stick figures will represent actors. These would be entities that would interact with the system. And that's what we're thinking about. Entities that would be interacting with the system are users of the system, and the different types of users, if you remember. Okay. And then we said that these ellipses represent use cases. So it's like things that actors would be doing. Like a medical receptionist, once interacting with the system that we are representing here, will be able to register a patient. They will view personal information. A manager will generate a report, export statistics. A doctor will view a record, edit a record, generate a report, set up a consultation. Yeah. I also made mention of the fact that the notation here is not exactly correct, because in an ideal case, the very first thing you do is you explicitly come up with a system boundary, if you will, and within that system boundary is where you slot in these use cases, the ellipses. The actors will ideally have to appear outside of the system boundary, and then the notation is such that your primary actors on the left side of the system boundary and your secondary actors on the right side of the system boundary. And in as much as we are providing simplistic relationship between the actors and the use cases, it turns out that there are other relationships that exist, relationships amongst the different sort of actors, like generalization, for instance, or relationships amongst the use cases, but more on that later on. Now, today we want to focus our attention on this document, right? The end product of the requirement specification phase, if you will. Apologies for that. There was a bit of noise. I think I have new neighbors here, and they have very unruly kids or something like that. I don't know which part of the world kids are screaming at night at 18:10, but I don't know. It's almost like we're living in the 1950s here, but that's okay also. Right? So it turns out, right, this SRS document, or the software requirement specification document, SRS is short for software requirement specification. So this SRS document really is usually referred to as an official statement that outlines what is required of the system developers. And I'm a bit hesitant about saying system developers here, but it's fine, right? We can get away with this. In other words, what we're saying is it is a document, it's an official document that stipulates what the people writing the software are going to be expected to do. I see Miss Tembo has her hand raised. Please, Miss Madam.
It's Miss Mtonga. So I wanted to let you know that I'm using Miss Campbell's phone as well because my phone has gone off.
Uh-huh. Yeah, I don't know about that, right? Okay. Uh, you're going to have to help us verify these things once we compile the scores here. I'm going to be sending out the scores over the weekend, by the way, for attendance. So we'll rely on you to let us know, to say on this particular day I attended, but I was using Namakau's computer or phone or something like that. Anyway, so an official statement, right, that outlines what the developers are supposed to do. Now, the
All
thing
right,
about
thank you.
yes, thanks. The thing about this document is, ideally, if you remember our definition of requirements, at some point we made a distinction between user requirements and system requirements. It turns out that this so-called SRS document or software requirement specification document is expected to include definitions of both of those types of requirements. Okay, so both your user requirements and your system requirements. Now this is interesting, right? Because if you remember, what what we what we discussed when we were looking at requirements, we discussed user versus system requirements. We also discussed non-functional requirements versus, or we discussed FRs versus NFRs, right? Functional requirements versus non-functional requirements. When we were discussing functional requirements, for instance, we said that your functional requirements, FRs, are supposed to be represented by highlighting specific user requirements and also system requirements. Very important, right? In addition, I guess everything is important here. In addition, we said that non-functional requirements are equally supposed to be expressed in such a manner that they specifically outline the system requirements and the user requirements. I hope you have not forgotten that. Something else worth mentioning from the outset is the fact that this SRS document is not a design document. Now, usually people misrepresent it or consider it to be a design document because it turns out that there are certain design artifacts that you would employ for you to express these requirements. Like, for instance, your ER diagram or your high-level architectural diagram that you slot in your system perspectives. All of those things are design artifacts, right? And so sometimes people misrepresent it as being a system design document or an SDD. This is us putting it out there that an SRS document is not a design document. In an ideal case, what you must do is you must prepare two separate documents, an SRS document and an SDD. So a software requirement specification document and a software design document. Two separate things here. And really, for the most part, what this document, the SRS document, should do is it should set out what the system should do, for the most part, rather than how it should do it. So you are decoupling design from specification, in other words. Okay, what is the system going to be doing here? And again, we want to draw your attention here to the diverse set of consumers of this SRS document, right? So a reminder here that consumers of your document are going to be system users, for instance. So these are users that are going to specify the requirements and validate them, verify, right, to ascertain that they truly represent what they expect of the system. Okay. And in fact, the reason why your system customers are a consumer is fundamentally for them to outline or specify modifications to these requirements in the event that there are certain things that have been misrepresented. But also, from the perspective of, let's say, the consulting firm, we see here that the SRS document will be used by managers for that organization, right? For them to plan for a bid for the system and to plan for system development process, in other words. Anyways, thought I would mention that here, right? It's also important for you to make this distinction because there may be instances when you find yourself outsourcing, certain activities. You have this software development firm like Probase, and NAPS has given you this massive contract, and you have to deliver in a short space of time, but you don't have the expertise. What do? You look for a company that is able to do the work you are incapable of doing, and then you give them a share of the proceeds, right? You're getting from ZRA in that particular case, or NAPS or something like that. So you have your system customers, you have your managers, but also, and by the way, what you notice is that all of these consumers of your SRS document here are what we introduced as stakeholders. So we see that system engineers, right, will use the requirements to understand the system that needs to be developed. The quality assurance engineers or the system test engineers will use the requirements to come up with validation tests. Okay? Validation tests that are going to be used to assess or assess the system once implemented. And then we see that the so-called system maintenance engineers could potentially use these requirements to understand the system and the relationships between the different constituent components of the system itself. Hope this is making sense. Now, the obvious question to ask here is, well, what is the structure? How should we structure this document itself? If you remember on the guidelines we had provided early on in the discussion of module number 5, we highlighted this notion that you want to make sure that you take a more structured approach as an organization. You come up with some document, some template or something that you're going to consistently use or apply to any type of project that you'd be working on as a company, right? And so what we're saying here is that the thing to do if you're a software development company, like in your respective groups, is rather than reinventing the way, what you want to do is you want to adopt an already existing standardized way of creating an SRS document. So you adopt an SRS template. Okay. And really, if you crawl through the web, if you do a bit of looking around, what you begin to notice is that there are a number of templates that can be applied, a lot of them. What we do in 3020 is we make use of an IEEE standard. So there's the IEEE standard 830-1998. And we use this as a basis to teach you how to structure an SRS document. It turns out that if you look at the subsections of this document, really, the document is typically organized in such a way that the average person who's been trained to read and understand requirements will be able to understand a document if created using this standard. Okay? And really, once you create this document, it turns out that you ultimately would come up with a document with a structure similar to the table of contents outlined here, right? So the document would have an introduction section, an overall description section, um, system features, any sort of external interface requirements associated with the system that you're developing, things like non-functional requirements that wouldn't already have been outlined in section 4, for instance. Yeah, so this is the structure that you'd come up with. Now, in the event that you're wondering, so what exactly is it we put in these different sections? It turns out that the IEEE standard does outline these things, but we're going to regurgitate these and discuss them nonetheless so that people understand. So your introduction, if you notice here, will have things like, if you look at the sections here, there's a section that outlines the purpose of the document, I suppose in this particular case, any sort of document conventions that you're using. Explicitly, a section that explicitly states the audience, right, for whom this document is created for. Things like the project scope and any sort of references, right, associated with the document itself. So important documents that you'd want to cite or something. Okay. So really your introduction, if there's anything, is project scope and reference. So your introduction will present an overview to help consumers of this document understand how this document is organized and structured, and more importantly, how they should use this document. So imagine a situation where you prepare an SRS document for ZRA. One of the things you do at the beginning of the document is you explain how this document is organized and how it should be used. And we see really that section tagged as purpose does nothing more than identify the product that is being built, the application that is being developed, right? And in essence, it's like, and also thinking about the product and the application is the solution for whose requirements are outlined in the document itself. It's like before you start describing the user and system requirements associated with the application that you're building, you must provide details about this application. And then the section tagged as document convention does nothing more than outline any sort of standards and conventions that are used. At a bare minimum, in your case, what we expect in 1.2 is mention of the fact that this document is being created based on the IEEE standard 830-1998, right? So that if I'm reading this document for the first time, I would know, right, the basis of why it was structured the way it was structured. Hope this is making sense here. And then we see here that we have project scope, right, where you provide a description of the software being specified and its purpose or something. And then finally, the references, we just outline or enumerate any sort of documents or resources that are referred to in the SRS document. Pretty straightforward stuff here. And I think what I'm going to do right now is just two things here. There's an SRS document for the smart IR deposit application, but we normally reserve that for your discussion in the tutorials. However, for the purposes of what we are doing right now, what I'm essentially going to do is I'm going to refer to the Zambia SRS document, right? And I'm going to go to the sections that we're from describing. In essence, section 1 here, right? You notice the structure. If we go to the introduction, there's mention of the things we're doing here, is it? Right? We're providing an overview, right, to help the reader understand. Yeah, we outline, and really, if you're saying you're using the IEEE, you don't necessarily have to use the sections or in the same manner that they appear in the document, right? It's a guide. The document is a guide. It's not a prescription. It's a recommendation. You can alter it and come up with your own. Uh, I want to say your own template derived from this. It's allowed. But usually, it's a lot easier if you just, if you just you use it in, especially if you're just getting started, right? You use it in its native form. Okay, it's like copy pasting or something. Yeah. So you notice here, right? If you read through the fine print of this SRS document, you notice that all of these things we're talking about will appear, like document convention. Document convention here, we are explicitly mentioning that this thing is loosely based on the standard. We're being explicit here, loosely, because we don't want people to be surprised when they're going through this and say, well, but there's this section that is missing. It's loosely based on that standard. We are outlining the intended audience. We are specifying the project scope, right? We are providing references. We are outlining definitions and abbreviations, right? All the good stuff. This is all section 1. So pretty straightforward, really. And then we see that in section 2, notice this document is organized in sections, not chapters. These are sections. So we see that, chapter 2 outlines the overall description. An overall description enables you to describe the product. We provide an overview of the product and the anticipated operating environment. It's like if you're building, if you were tasked to build SIS for UNZA, what you'll be doing in the overall description is you'll be describing SIS, right, broadly, at a very high level, right? You're abstracting these details, and it will make sense when you look at examples. And in addition, describing the environment within which SRS is going to operate. So in this case, it's the UNZA environment. And if we look at the specific subsections here, we begin to notice interesting things, like, section 2.1 is supposed to be an outline of the so-called product perspective. And in the product perspective, we are expected to describe the context within which this product is going to operate, and perhaps its origin or something. And in fact, if you look at examples, what you notice, or if you look up just SRS documents on the internet, on the web, what you begin to notice is that for the most part, what most business analysts creating these SRS documents will do is almost always they'll include what's called a data flow level 0 diagram or a context diagram. Okay, and we'll talk more about the context diagram just now, but in essence, what we're talking about is this. Okay, you're showcasing the product's context. In a context diagram, your product is at the center of everything, and there's a convention. We're going to discuss this convention, and then what you do is you're describing this context relative to the messages that are being exchanged between the system and external entities, other systems, or perhaps system users. Okay, so that's a product perspective. And then we see here that you also provide an outline of if you look at the thing here, there's like product features here. It's a high level overview of product features, things that you describe in detail under the section system features or something. If you're using these IEEE standards, appendix section A.5, I believe it is. In addition to product features, what you do is you provide a description of user classes and characteristics. So in essence, you go through this detailed exercise where you anticipate the different types of users or user categories that are going to interact with the system. So it's like in the case of Moodle, it's like, oh, students are going to interact with the system. Okay. Lecturers, tutors, those are the different user classes. Eventually, at some point, what you do is you get to a stage where you obviously will, in terms of user classes, you narrow down specifics, right? But at the level when you're preparing the SRS document, you don't have to come up with the exact actual categories of how these user categories are going, or roles are going to be named, right? They may change eventually, but you're just identifying these distinct classes, like different types of users in essence. Okay. And you're doing this by anticipating, right? Well, say, well, the system we're building is going to require a super user, an administrator, so that's a class. It will require a content administrator, a content manager, or something. That's a class. It will require a public user. That's a different category of a class or something. So you do that. Then also, we see that we are expected to outline the operating environment. So the idea behind the operating environment here is simple, right? It's like, where is this piece of software going to be deployed? And the moment you start thinking about where the piece of software is going to be deployed, you start thinking about the broad spectrum of all of these dependencies, right? You deploy software, or you install software on some piece of hardware. But in addition, there's like software components that are required. So in terms of the hardware here, it's like the compute specifications, is it? RAM, processing power, right? Storage specifications, is it? And then in terms of software, you're talking about obvious things like the operating system, for instance. It's like, well, what about any other interesting components like interpreters, right? Or perhaps to a certain extent, relational database management systems, for instance, right? Are there any sort of web servers that are required or something? We are building a web-based application. Well, if you're building a web-based application, what technology are you using? We're using Java. Okay, if it's Java, we know that we need a servlet container, for instance. All right. Yeah. So in essence, what you're doing under operating environment here is you're outlining a comprehensive outline of the hardware platform required, operating system specifications, including versions, right? And any other component, software components. It's like you want the user to know that once we are done building this piece of software, you better make sure that you have a Windows operating system ready, or an Ubuntu 24.04 operating system ready, or something like that. You better prepare or brace yourselves for managing a servlet container like Tomcat, okay, or JT, for instance, or JBoss, or whatever fancy servlet container you'd want to use here. And then in 2.4, you'd be, I guess 2.5 or something, you'd be outlining any design and implementation constraints. So these would be things like, oh, what sort of programming languages are we going to be using? Are there any specific libraries and frameworks that we'll use or something, right? And then, you then have an outline of any sort of assumptions and dependencies associated with the software that you're developing here, right? These are assumptions tied to the business processes for the organization for whom you're developing the software, for instance, or any other external factors, right? Or components that would be outside of your control. Anyhow, so in essence, right? If we were to look at the section 2 here, see how it actually looks like. This is the actual manifestation of section 2, overall description, where you have your product perspective, right? Pretty intuitive. Pretty intuitive here. You're describing the context and the origin. And the telltale signs that you're describing the context here is the data for level 0 diagram here. You have your product features. These are high-level features, right? We are going to build a Moodle, and it will allow lecturers to upload materials, to administer assessments. You're being vague, right? You're providing these high level descriptions of what the system is going to do. But you know that there are these gory details regarding administering of assessments, right? Like, oh, you create a quiz or something and all those things, right? This is how you grade it and all those things. Anyways, so as a product, this is product features, high level overview. And in this ZEMA SRS document here for the RAI platform, the Register Environmental Information Platform, what we did was we tried to provide a more detailed, high-level description of the features, right? High-level description of the features. The interface, we have a very nice high-level architectural diagram here, different layers here, the user interface, service layer, and the repository layer, and all those things here. And then under user classes, if you look at how we are presenting this information in our case, we just use a table. We have the user class and the description of that user class. That's it. Okay. And then under operating environment, you notice here, if I'm to kind of like scroll down here, telltale signs here are things like, oh, we won't be we're developing this system by assuming that it's going to run on the Ubuntu operating system. And in particular, to be specific, it's a 20.04 long-term support version of Ubuntu for Kofaso, right? And we're specifying details of against this operating environment. Nothing like we're going to deploy this in the cloud. It will be deployed on servers hosted at ZEMA. Providing details like we're going to develop this using PHP, for instance, right? And then we have an enumeration here of specific technologies, right? Operating system, specific web servers here that are going to be used, and the versions, including the functionality and the justification, right? We're being detailed here. Specific languages that were going to be used for implementation of the backend services and the versions. Specific frameworks. Here we're using PHP, but we're not just going to use native PHP. We're leveraging a framework called Laravel, right? What else are we doing here? If you notice, we're specifying against this operating environment because this is a data-driven application. We're saying the database is going to be implemented using MySQL, including the version. I don't know about the management here. I think this was a bit of an overkill here. In terms of the front-facing part of the application, we're saying styling is going to be done using Bootstrap, right? Interactivity on the front end is going to be it was going to be done using this JavaScript framework called jQuery, for instance. A whole range of things. And then in terms of secure connections here, we see here that we're going to use DigiCert SSL certificates, right? So that when this web application is being accessed, the address will be like HTTPS, not HTTP. You understand? I mean, this is how you represent this sort of information. And you see, the key thing here is you're being detailed because the people that are going to read this information are going to need these details. The deployment engineers, right? DevOps, the people testing this piece of software need to have this information in mind. The client needs to prepare. Well, we're going to use Ubuntu, okay? What sort of server infrastructure is going to make it possible for us to run Ubuntu, for instance? Anyways, and then if you notice here, we have like our design and implementation constraints, right? We're outlining any sort of business constraints. These are linked to ZEMA, any technical constraints, right? Timing constraints, hardware constraints, right? And then we're talking about things to do with the project scope, any network constraints, things that can act as hindrances to what we are doing, in essence. And then if you look at the assumptions we are making here, right? I don't know, it's what these are. They're just assumptions we're making about the system development itself, right? We're assuming that the people that are going to be using this piece of software are computer literate, for instance. They know how to use computers. Anyways, and then if you look at dependencies here, I guess we are tying this to human resources at Zem or something. So in essence, really, if you look at how you structure the section 1 and section 2, this is it, right? This is it. And really, if you stop and think, you begin to notice here that what we've outlined in section 1 and section 2 has very little to do with the system features, the functionalities. I mean, there's a vague reference to these things, like when we're talking about product features in section 2, but for the most part, right, maybe to a certain extent, maybe design and implementation constraints, but for the most part, the focus in section 1 and section 2 have little to do with the actual specific functionalities of the system. Something else that's worth mentioning here is that section 1 and section 2 are represented at a very high level, right? This is a really high abstraction of what is being done. And so it goes without saying here, if you think about it, that typically section 1 and section 2 is reserved for your clients, for the most part. I mean, sure, technical people like developers will need to read that document, but you begin to notice here that as you're talking about operating environment, this is like information that your customer is going to understand easily. It's represented in natural language notation, right? It's a high abstraction of what you're doing here. Now, after section 2 comes your so-called system features. Okay. Now, the thing about the system features, if we look at the IEEE standard 830-1998, we begin to notice that we can represent these system features or functionalities in different ways. Okay. So if you go to the specification itself, you notice that the range of templates that are provided, like for instance, there's a template in appendix or annex A.1, for instance, which organizes the requirements by mode. Okay. And then there's appendix A.2, which again organizes requirements by mode, but in a sort of like different manner. Observe, in this particular case, in A.1, you have like section 3, which is specific requirements, and then you have 3.1, which is external interface requirements, and then 3.2 is functional requirements. But in A.2, your specific requirements are all organized under functional requirements as functional requirements. So it's like you refactor the modes of the system from the functional requirements. In A.3, we see that the organization is by user class. So this notion that using the categories of users you've identified, I'm going to have a lecturer and a student and a tutor. It's like, well, can you then come up with requirements that are specific to a student, to a lecturer, to a tutor, right? So you see here that the functional requirements are going to be organized by user classes. And then you have A.4, where you're organizing the requirements by object. So this is in instances where you've taken an object-oriented programming approach. So it's like you look at your system and you say, well, the system we're building, which is Moodle, is going to have a student class, a lecturer class or object. It's going to have a grade object or class. And so what you start doing now is start organizing these functionalities based on these different objects tied to the system you're developing. It should be perfect for you guys, right? Because you have been trained in the art of object-oriented programming. Anyways, and then my personal favorite, Annex A.5, where you are organizing the requirements by feature. So you identify these high-level features, right? It's like we're going to have a grading feature, a resource upload feature or something, a communication feature. And then for each system feature, you start identifying things like specific requirements associated with that. So it's like a grading feature will enable a lecturer to, or rather maybe a resource upload feature will require a lecturer to upload presentation slides or something. to create resources right within Moodle or something like that. Anyways, that's 8.5. The key thing here is that irrespective of which sort of template you decide to use or how you want to organize the requirements using this standard, the document, the IEEE standard itself, has details of how you organize this information, guidelines in essence, right, in the document itself, specific guidelines. Okay, so when we meet next time on Friday, wait a minute, no, when we meet I don't know if it's tomorrow or something. This is crazy. It's tomorrow. Wow. When we meet tomorrow at 14 hours, what we are going to do is we are going to focus our attention on how to structure these requirements using the template in the Annex A.5. So we're going to be looking at how we organize requirements by system feature, right? So we'll go through these things here together, one at a time here, so that we get you to a stage where you're able to prepare this SRS document in your respective groups. Deadline is the 8th of August. I'm going to pause here. I'm looking at the time and ask if there are any specific questions about this. Okay. If there are no questions, we can leave it at that. I will see you tomorrow at 14 hours. Thank you very much.